Selection sort is a sorting algorithm that treats the inputs as two parts. There's a sorted part and an unsorted part. This repeatedly selects the proper next value to move from the unsorted part to the end of our sorted part. That'll make sense when we actually code it, and we're going to code this in descending order. So our bubble sort looked like this, and our selection sort is going to look like this, so in the opposite direction. In selection sort, we're going to first have a loop that goes over everything except for our last row. So it's going to be similar to this bubble sort. In fact, we can copy this whole first part, but just modify it a little bit. So moving this over, we are going to have system.out.println, and this is going to be selection sorted array. So we have this first for loop, and we should put our ending brace right here, and then we can go inside of it. So what we want to do is basically look over the entire initial array, and in fact we're actually going to be looking at only this column, the second column, 38759. So we're looking over 38759, and what we want to do is we want to go through the whole column and compare each of these values to the first value, and then the second value, and then the third value, and so on. And basically we're going to find the smallest and move them to the front. So inside of here we are going to basically get the smallest index first. So we need something to store this in. It's going to be int, and we will call this index small, and then we're setting this equal. Initially we'll just set it equal to 0, and then we're going to want a for loop that compares every value in our column. So inside of here we're going to have a for. It's going to be int, and this int is going to be equal to a plus 1. And the reason why it's a plus 1 is because just like in the bubble sort, where we had it be row minus a minus 1, we don't need it to look over every single thing. We don't need it to look over the values that are already sorted. So once it does its thing, it's going to just be like this. As a matter of fact, if we wanted to, we could just do int b, and then we're going to have b is less than row minus a minus 1. We'll also initialize b to 0 if we're going to do it like this. And then we're just going to have b plus plus. And now we're going to be inside of our for loop. Inside of our for loop, for selection sort, we're going to say, well, if our smallest value is greater than the current value, we will swap these values. However, we check every value that we have not sorted in our column before we swap. So we're basically going through this whole time. And I think this should be a will. So after we know this, we have this written out, we know what to do. And so if our smallest value is greater than the current value, it means we need an if statement. So we're going to look at our smallest value. We're going to say if the array at the b, and so this is the exact row that we're going to be looking at, if b is less than, or I'm sorry, if array b, and then we have to do the second index because it's a 2D array, and we're going to be in the first indexed or the second row, so we're going to have it be 1, is less than the array, and then we're going to have the smallest indexed because we're going to be comparing the smallest index. And at the beginning, we're going to set our smallest index to be the very first value. So what this is saying is we have this array right here, and it's looking at this column. Well, if the array b1, so if 9 is less than our smallest, this is going to be 0, 1, then we're going to be in here. Well, we're going to be comparing 9 to 9, and so we won't be in here. Next, what we're going to do is, because smallest index is still going to be 9, but however our b is going to be incremented, we're going to have 1, 1, which will be this part, and we're going to compare it to our 9. And so now we need to go inside of our if statement and we're going to need to make our smallest index, which should actually be index smallest or index small. We need to make this value, because this value is obviously the smallest index. And we're only taking the actual index, not the value, I'm sorry. So we're going to set index small equal to b. And this is going to store the new smallest value, because this value is obviously smaller than this one. So now that we have this, what we're going to do is we are going to, and this is after we've gone through every value in our column, we'll come outside of this loop right here, and we are going to make a swapping. And this is similar to what we did with bubble sort, where we performed the swap here. So we're just going to be performing swap. So inside of here, we're going to need a for loop, int c is equal to 0. And this for loop is only because we have to swap all of these columns. So now we're inside of here. We can make a temporary value, just as we did up here. It's going to be very similar. We're going to send int temp equal to our array, and we're going to do, instead of here, let's say we have array bc. Since we're doing it in descending order, it should be for this one, sorry. Since we're doing it in descending order, what we're going to do is we're going to do row -1. That way it will start from down here. And then because of this and because of our previous code, it's not going to look at these bottom rows anymore. And then it's just going to keep going up and up afterwards. So we're going to set it to C. That way it will look at all of the columns. Now what we need to do is we need to take this, and then we're going to set this equal to our smallest index, because we want to move our smallest index to this place, and then to this place, and this place, and this place. So we're going to have it like this, and then we need to make the array smallest index, which is the part where we're swapping it with, equal to the temporary value. So we're just going to put temp in here, and then we're going to place this 1 with C and replace this 1 with C, and so that should fix it. Now we can run this. We have our initial array. We have the bubble sorted array. We don't have a selection sort array, and that's because I never added this toString to print it out. So this is from our bubble sort, but all we're doing is just calling this. So we can come out of our last for loop, paste this in here, and we can run it. Looks like we have another error with it, and this error looks to be from this for loop. And when I said that this was the same as this, I guess that's not entirely true, and that is because the way that the descending works, and the way it works with this code. We want our we want our B to be going up every single time. We don't want our row to be going up every single time. When we had it up here for the bubble sort, it was a little bit different, but for here, what we want is we want our B to go up to the next value, and this is because we are not going to be looking at the lower values anymore. In the bubble sort, we weren't looking at the higher values. So if we run this now, it should work. We have a 9, 8, 7, 5, 3, and we can see that our columns swapped accordingly. And then our array was not copied correctly. So let's go back up here and manage that. So printing out the initial array, sort.toString array. Well, we did set our array equal to temp, but it seems like when we set it here and here, what ended up happening was it didn't copy over correctly. And this might be because we have to execute this every single time our code runs. So if we paste this right here, we can run it again, and we see that it has been copied correctly. So every time our code runs, we are going to need this temp right here. So we're going to need it to print our shell sort, and this should be the insertion sort. So we just need that temp is equal to sort.copy. So I guess that means we have to copy it over every single time for it to copy correctly. And so that's our selection sort done. We've copied it. We've proven that the copy works back to the initial array, and our bubble sort works in tandem with the selection sort. So now I'm just going to move this down here, or I'm going to move it underneath our shell sort. because that's what we're going to be attempting to run next.